Hello guys, in this video I would like to explain about how to solve any series or parallel combinations of resistors with the help of these 5 examples. So let's start. First I will explain the common concept how to solve the 2 or more resistors in series or parallel, so that we will derive the final formula of series or parallel combinations of 2 or more than 2 resistors connected in series or parallel. For example, these are 2 resistors. I will name them R1 and R2. If two resistors have only one common terminal, these resistors are in series. Another way, if two resistors have start and ending point of the resistors are in common, it means these resistors are in parallel. So how will I derive the formula for two resistors? R equivalent will be R1 plus R2. For these resistors, R equivalent will be, this is their shortcut formula, R1 R2, their multiplication divided by their addition. So to solve the example number 1, in order to solve any example, you have to start from right hand and to solve until you find R equivalent resistance. From here you can see that 5 ohm and 1 ohm, these have only one common terminal. It means these are in series. Their series combination will be equal to R1 plus R2. It means 1 plus 5 is equal to 6 ohm. Up till here you have solved it, and you have to put here this resistance. Up till here the resistor will be look like this thing. Okay, this will be connected as 6 ohm resistor. One terminal is here and another is here. So next you have to solve, look into here, 6 and 3. Here one terminal is common here. See here, this is the common terminal and another is here. It means these are in parallel. Their parallel combination will be equal to Req1 is equal to, parallel combination has R1 into R2 multiplication of two resistors and divided by their sum. So 6 multiplied by 3, 18 divided by 6 plus 3 is equal to 9. 18 divided by 9 is equal to 2 ohm. It means we will connect 2 ohm resistor here. Okay, 2 ohm resistor. So just we have to write it, the new circuit, it will become 4 ohm, and this was 2 ohm original and new 2 ohm is connected here. That was combination of 6 and 3, and 5 ohm was connected here. 5 plus 1 combination of series, that was 6 ohm. It is 2, it is 2, it is 6, it is 4, and here this was common and we have 8 ohm resistor here. That was this resistor. This is our equivalent. So 2 plus 2, they have one common combination, one common point. This will be in series. 2 plus 2 will be 4. 4 in parallel with 6 will be 4 into 6 divided by 4 plus 6, that is equal to 24 divided by 10, that is equal to 2.4. So insert it here. We have solved up till here. This was become 4 ohm. 4 ohm, 2 plus 2, 4, 4 in parallel with 6 we have found here, and this will become the new circuit of 4 and 2.4 here, and 8 is here. See here, 4 and 2.4 have one common terminal. 2.4 and 8 have one common terminal. It means these all resistors are in series, and R equivalent will be equal to R1 plus R2 plus R3. This is equal to 14.4 ohm. This is the final equivalent resistance. So summarize it. In order to solve the resistors, you have to look back in order to find the final equivalent resistance. So 5 and 1 were in series. It was 6 ohm. 6 ohm was here, and you have to solve 6 and 3 in parallel. Their combination was 2 ohm. So 6 ohm was connected up till point A and point B. This is 6 and 2, and their parallel combination was 2. This is connected here. 2 plus 2 is equal to 4. 4 in parallel with 6, that has 2.4. 2.4 is connected here, and 2.4 is connected here. 4, 2.4 and 8 has series connection. So the final resistance is 14.4 ohm. So this one example is summarized up, and now go to example number 2. in this example, you have to look back in order to find the equivalent resistance. See here, 3 and 5 have one common terminal. It means 3 and 5 are in series. 5 and 4 have one common terminal. It means these are also in series. It means 1, 2, 3. These three resistors are in series. Their equivalent resistance will be R1 plus R2 plus R3, that is equal to 4 plus 5 plus 3. It means is equal to 12. This resistance will be connected up till these points. In these points, because this was the solution of these three resistors. So 12 will be in parallel with 4 ohm. So I will solve it here. This will become 4 ohm and this is 12 ohm. 4 and 12. You have to look back to reach till 5 resistors. So you have 4 and 12 in parallel. Solve them. R is equal to, in parallel, R1 multiplied by R2 divided by R1 plus R2. This is the parallel combinations of two resistors. It means 48 divided by 16, it is equal to 3. Their combination will be 3 and 3 will be connected up till here, these terminals. So 3 is connected, for example here, this is 3. So check here, 3 and this 3 have only one common terminal. It means 3 and 3 will be in series, and 3 and 3 will be in series. If we solve that, 4 ohm, 6 ohm, 3, 4, 6, 3, and we have 3, and we have solved up till 4 in parallel with 12. That was 3, 3, 3. Look at here, 3 and 3 have one common terminals. It means 3 and 3 are in series. This their combination will be 6 ohm. 6 ohm will be parallel with 6 ohm, and 6 in parallel with 6 will have 6 multiplied by 6 divided by 6 plus 6, and it will be 3. So 3 will be here up till here. So 4 in 4 ohm, 3 ohm and 3 ohm. 4, 3, 3. It will become series combination because 4 and 3 have one common terminal. This 3 and 3 have one common terminal. And this is your look back resistance R equivalent. It will become 4 R1 plus R2 plus R3. It means R equivalent will be 10 ohm. This is your final solution. You have to look it again in order to summarize the results. 3 ohm, 5 ohm, 4 ohm were in series. Their series combination have summation, and that will be 12 ohm. 12 ohm is in parallel with 4 ohm, and their parallel combination had 3 ohm resistance. So up till here 3 ohm was here. So 3 ohm was here. 3 has one point here and another point is here at bottom of 6. 3 plus 3 were in series, and there will the summation was 6. 6 in parallel with 6 and 3, and 4 the resultant 3 and 3. 4 resultant 3 and 3 were in series. Their summation was 10 ohm. For example number 3, we will solve this circuit. We have first to identify that which resistors are in series and are in parallel, and after that we will solve by look back method. See here, 12 and 4 resistors. These have one common terminal here, okay, and 4 second and this terminal here, and 6 and 3. Look at 6 and 3, their starting point is common and their ending point, 3 ending point and 6 ending point, this is also common. It means 6 and 3 are in parallel and 12 and 4 are in parallel. So solve them and write their values. 6 and 3 value will between them, and 4 and 10 value will be between them. So 6 and 3 as 6 multiplied by 3 because they are in parallel. 6 plus 3, this is 2 ohm, and 4 and 12 was 4 into 12 divided by 4 plus 12. It is 3. So put back these values and you will get the equation. This is 10 ohm and next is 1 ohm, and next is also, this was B, and next is 1 ohm as well. This is 5 ohm, and beneath it it's nothing, and up till this point. This is point number B. Look into here. D and B were 6, 4 and 12 parallel combination. It means D and B have 3 ohm resistance. That was parallel combination, 3 ohm resistance. and C and B. C and D had 1 ohm resistance, that is here, and this is C and B terminal. This is B terminal because this is connected by a wire. C and B terminal had 3 and 6 parallel combination, that was 2 ohm, and this is 10 ohm. See here, 5 and 1 is in series because they have one common terminal. 5 and 1 is 6, and 6 in parallel with 3. Their whole combination will be in series with 1, and their resultant will be in parallel with 2. The whole resultant will be in series with 10. That will be final answer. It means 5 plus 1 is equal to 6. 6 in parallel with 3. You have already solved, that is 2. 2 will be here, and if 2 will be here, if 2 will be here, 2 will be in series with 1, that will become 3, and 3 will be in parallel with 2. 3 in parallel with 2 will become 6 by 5. Okay, 6 by 5 will be in series with 10, so our equivalent will be 10 plus 6 by 5, that will be 56 by 5 ohm. You will round it off, and it will be the final equivalent resistance of that circuit. Example number 4, and you will first you will identify the series and parallel resistors. After that, you will look back method to find the RAB resistance. See here, 20 and 5 have common start terminal and other common terminal. After that, you look into that. 20 and 9 are not in parallel because 2 ohm is in between them. Now 18 and 9 are in parallel because they have common terminal here and other as common terminal here. This is the common terminal. It means 18 and 9 are in parallel, 5 and 20 are in parallel, and solve them, you will get the answer. 5 and 20 is 20 multiplied by 5 divided by 20 plus 5, it is 25. 100 by 25, it will be 4. It means here the resistor connected will be 4 ohm. It will be vanished. Okay. This is 4 ohm resistor. Look at here. 4 and 1 are in series. 4 plus 1. It will become 5 ohm resistor. It means 20 and 5 will become in parallel. 20 and 5 will become parallel. So 16, 20 and 5, 25, and after that these were in parallel, and after that this is 2 ohm resistor, and 19 and 8 will be connected. 9 and 8 combination will be connected here between 16 ohm and 20 ohm joint. Okay, this was the point, and here was the combination resistor of 9 and 18 ohm. 9 and 18, 9 multiplied by 18 divided by 9 plus 18, 162 divided by 17, and you will get the answer of 6. It means you have 9 and 18 combination as 6 ohm. See here, 5 and 2, 20 are in parallel. Their whole combination had this common point, and 2 will be in series with that their combination. 5 the 5 and 2. 5 and 20 parallel combination was 4. Diminish them and write the answer of parallel combination. 4 and 2 will become 6 ohm resistance. So you will write the 6 ohm equivalent resistance. 6 will be in parallel with 6. Okay, 6 will be in parallel with 6. 6 into 6 divided by 6 plus 6, that will be equal to 3. So put back the 3 ohm resistance here. The resultant of this triangle, it will become 16 and 3. 16 and 3 will become in series because they have common connection. So 16 and 3 will be equal to 16 plus 3, and R equivalent will become, R equivalent is equal to 19. Summarize it. If we summarize the circuit, if you identify that which resistors are in series and parallel, the solution will be found here. 20 in parallel with 5, 9 and 18 are in parallel with. If you solve their circuit, and the resultant will be in series with this one, and their whole combination will be in parallel with this one. After the solution, that will be in series with 2. After that, here it will be one resistor. You can solve 19 and 8 ohm, and after that, that will be in parallel with that, and 16 ohm in series, and RAB will be found here. In example number 5, you have to look back in order to find the final resistor, and first of all check which resistors are in series or in parallel. See here, 180 and 60 have one common point. It means 180 and 60 will be in series, and their whole combination has starting point here connecting with 60 and their combination has ending point connecting with 60. It means their combination will be in parallel with 60 ohm. 180 and 60 will be 240 and that will be connected here. It means 240. 240 is connected here. This is vanished. This is vanished. No. 240 and 60 will be in parallel. So 240 and 60 will be in parallel. Their equivalent resistance will be 60 into 240 divided by 60 plus 240. It will be 48. So the resultant will be 48. 25. This was 240 in parallel with 60 and their combination has 60 into 240 was 48 and this was 25. Their resultant will become 25 and 48. 48 and 25. Solve it, you will get R equivalent is equal to 48 plus 25, that will become 73. So R equivalent is equal to 73. That is the final solution of the R equivalent for this circuit. Hopefully you have got clear idea that how to solve the series and parallel combinations for any circuits. Thank you for watching my video. Please like, share and subscribe to my channel.